Let's continue our review sa organic chemistry. We are done with the namings last time. I had a separate PowerPoint presentation for that, but I have already posted the recorded discussion, so you can review that. Now let's move on to our isa-isahin na natin yung mga functional groups natin sa org-chem. So number 1, we have here the simple hydrocarbons. When you say simple hydrocarbons, you just have hydrogen and carbon in the structure. And simple lang kasi hydrogen and carbon lang talaga, walang ibang atoms or elements involved. So we have 3 types of simple hydrocarbons. We have the alkanes, alkenes, and alkynes. Actually, we will also include the aromatic compounds here since yung hindi substituted aromatic compounds, hydrocarbon pa rin naman. Now, let us start with the alkanes. So when you say alkanes, ito yung hydrocarbons that single bond lang yung involved when it comes to the linkage between a carbon and another carbon. So other name of alkanes, we have paraffins or saturated hydrocarbons. These are called saturated because they are saturated with hydrogen since they only contain single bond between carbons. So daghan kaayo sila og hydrogen kaya tinatawag na saturated hydrocarbons. Now in organic chemistry, we have the so-called hybridization of the energy level or the orbitals. Wait lang, I'm looking for my pen. Ayan, again, in organic chemistry, we have the so-called hybridization class of our orbitals. Remember, when you say orbitals, this is where we can possibly see or locate the electrons of an atom. Now, pagdating kasi sa organic chemistry, it's a bit complicated because as the different atoms join together or are linked together, nagkakaroon ng merging of the different orbitals of these atoms. So yung mga orbitals like diba SPDF natin, magme-merge sila and most of the time it's between the S and the P orbital. Now, for the alkanes class, yung kanilang hybridization is sp3. So para madali yung ating hybridization ng ating orbitals. Ito yung gamitin ninyo na na table para mas madali niyo siyang matandaan. Like we have, we have the groups here and then the hybridization. Hybridization. So remember, di ba, meron lang tayong isang s orbital and then di ba, yung shape niya is spherical. But for the p orbital, we have 3 types of p orbital. Kaya nga, di ba, tatlo yan siya pag i-fill in natin, tigdadalawang electrons. So yung ginagamit natin dito is px, py, and pz. Yan yung mga names ng mga orbitals. Now, please copy this 1, 2, 3, 4 and then ito yung hybridization.
Ma'am.
Yes? Yes.
Bago na ako sulod, ma'am, kay wala internet kay na nagaano siya connecting.
Okay. No problem. And then we have the SP, SP2, and SP3. So, anong ibig sabihin nito? Example, we have this alkane. Actually, this is the ethane. 2 carbons involved in the bonding. Ay, na naman na. Erase. Then we have H and then H. Now, look at this. This one is a single bond class. Okay? Tarungan ako siya sulat. Single bond siya. And then the bonding involves the orbitals of the electrons, right? Remember, chemical reactions happen because of the electrons. Now, in this case, there will be merging of the s orbital and the p orbital. Pero kung how many p orbital, malalaman mo yon sa number of groups being linked in that certain carbon. So let's start with this carbon number 1. Actually, the hybridization of this is sp3. We have, paano natin i-count yung groups? Titingnan natin kung ilang groups din yung nakaband sa carbon. So like this one, this is counted as 1, 2, 3, and then 4. So this carbon class contains 4 groups linked together to itself. So pag 4 carbons again, or 4 groups, so whatever atom or whatever functional group is that, as long as 4 groups siya, yung hybridization ng electrons ni carbon will be sp3. Meaning there will be merging of 1 orbital, 1 s orbital, and 3 p orbital. So this is true for all alkanes. So this one, this carbon here, the second carbon here, sp3 pa rin yung hybridization ng kanyang orbitals. So ito yung nangyayari sa kapag ka organic chemistry na bonding. Magme-merge yung mga orbitals ng mga electrons nila. So do not forget, for alkanes, the hybridization is sp3. And yung hybridization, meron siyang effect on the shape of the molecule. Okay? So pag sp3 class, most likely the molecule will be tetrahedral. And yung angle niya is 109.5. So just like this one. So hindi talaga siya straight na pag you are going to draw the methane for the ethane, for example, hindi talaga siya straight class, including ang methane dyan ha. Magkakaroon ng angle yung bonding. You have the carbon here at the center, and then you have a 109.5 degrees na angle between this hydrogen bonded to the carbon. Okay, so we have here the methane again, 109.5, and this is what you call tetrahedral. Apat. You have 1, 2, 3, and 4. So yun yung totoong shape ng ating molecule or molecules for the alkanes, that is due to the hybridization again of the orbitals of the electron. So again, the type of hybridization for our alkanes is sp3. So I hope naintindihan yon. I will have more examples later of the other types of hybridization as we go along with our discussion, especially with alkenes and alkynes. Okay, now nomenclature rules for our alkanes. We have already discussed this last time. So if nakalimutan, please review the recorded discussion. Pag sinabing alkanes class, we have the general formula CnH2n plus 2. So again, if we only have one or single bond, single carbon to carbon bond, most likely the general formula will be this one. So N refers to the number of carbons. So for example, you have 2 carbons in your alkanes. So ang kanyang molecular formula will be C2H. 2 times 2 is 4 plus 2 is 6. So this will be the correct molecular formula for a 2-carbon alkane. Okay? Sundin nyo lang yung general formula natin. And then do not forget, alkanes only involve single carbon-to-carbon bonding. Now, in naming our alkane, mag-i-end yan sila always ng "ane". Okay? That's how you know that it is an alkane. But for the branches, again, this is applicable for the branches, yung mga sanga-sanga na or mga yung parent chain natin, and then merong mga sanga-sanga, merong mga substituents, we are going to use the alkyl. So hindi siya mag-end sa ane instead sa il. That is why we use the methyl, ethyl, propyl, and so on. When you say alkyl, it is actually an alkane but minus one hydrogen. So yan yung meaning ng alkyl groups natin. Again, it's an alkane but minus one or minus hydrogen, depende ilang na minus doon. Basta minus, most likely minus one na hydrogen. So again, in naming, this will follow our rules class na tinuro ko last time, yung gagamit tayo ng prefix na dependent on the number of carbons. Okay, and then again their names end with ane. So just like methane, meth because it has one carbon, and then since wala naman talagang bondings, pero walang carbon to carbon bondings, but meron tayong hydrogen to carbon bonding na single bond, then methane pa rin siya, alkane pa rin siya, so mag-e-end pa rin siya sa ane. So therefore, we have here the methane. Any questions so far? Pasig na ay wala na sabtan, ulito na to. Yeah. Wala. Sure na. Pasig habang nag-discuss ko din, nagluto mo din ha, panihapon. So, most likely, maugin na siya ang mahitabo, multitasking. But anyway, sige lang, pag naibili masabtan, pangutan na lang. And anyway, this one is being recorded. So do not forget our root words. For the number of carbons. So man, suggest na tama na kung gaingon, malagluto yun na sila din sa kailang panihapon. Okay, please memorize the prefix for the number of carbons. This is true for all the functional groups in organic chemistry. So this is not just applicable sa ating alkane. Gagamitin pa rin natin yan sa mga succeeding natin na discussion. Okay? But again, idudugtong natin siya sa kanyang ending na ane if single bonds lang lahat. The formula will follow the general formula CnH2n plus 2. But if ever a certain alkane is dehydrogenated, meaning nakuhanan siya ng isang hydrogen, that's the time it will become an alkyl group and hindi na siya mag-e-end sa ane. Okay? So, di ba pag gumagawa tayo ng chemical like structural formula, nangalak wala ng sulat. We have here, for example, this one. And then sa gitna, meron ka for example, CH. Hindi naman natin sinusulat na CH4. Instead, 'di ba, CH3 lang talaga siya. Makukuhanan talaga siya ng isang hydrogen class kasi hindi pwedeng sumobra na sa 4 ang bondings ni carbon. So do not forget that. Pag sumobra sa 4, most likely mali na talaga yung answer ninyo. Now, since that carbon is bonded to the parent chain, ika-4 nyo na yun na bond. So, CH3 na lang siya. So, from CH4, CH3 na lang siya. Hindi na natin siya tatawagin methyl. It will be an alkyl group. So, it will be called methyl. Ang ending nila will be il. Okay? So, please follow the previous table that we have for the prefixes used depending on the number of carbons. So na-mention ko na to kanina, alkyl groups are those alkanes with one hydrogen being removed. So just like this one, CH4, nakatawa ko sa nisulod. Ito mo, Movina. Moxin and Company. Okay. CH4, and then kapag naging branch siya, makukulangan siya ng isa. So, magiging CH3 na lang siya. So, we have here the methyl. Okay? Now, what are the things that you need to know about alkane? In general. and actually methyl group also. Number 1, alkanes can participate in van der Waals interaction and hydrophobic bonding. When you say van der Waals interaction, it means intermolecular forces, meaning it can participate into bonding with other molecules. But remember that these van der Waals forces or van der Waals interactions are weak. So they can also be broken. And aside from that, alkanes also participate in hydrophobic bonding. So when you say hydrophobic, phobia means hating. So like these are molecules that are water hating. So just like the fats, ayan, or yung mga oils natin, mga lipids natin, they are hydrophobic. And alkanes can participate in that kind of binding or bonding. Next, alkanes or even the alkyl groups can also be oxidized. So yung metabolism nila inside our body involves oxidation. That's how we eliminate or metabolize our alkanes. By the way, if alkane tapos nakuha na minusan ng isang hydrogen, we call that alkyl group. But if it is an aromatic ring, just like the benzene ring, tapos na minusan ng isang hydrogen atom, we call that aryl group. Okay? But instead of calling it benzene, we'll call it benzyl. Pero parehas pa rin sila ng ending. Okay? Il pa rin. Alkyl lang for the methane. For the aromatic ring or for the aromatic hydrocarbons, we call that aryl groups. Okay? So do not be confused with that. Now, other things that we need to know about our alkanes. The alkanes with 1 to 4 atoms, meaning methane, ethane, propane, and butane. Carbons, again, 1 to 4 carbons ha. Yun yung mga mabibilong dito. Again, methane, ethane, propane, and butane. They are gases class at room temperature. So do not forget, silang lahat at room temperature, they are gases and they are used as heating fuel. So just like butane, we use that one, diba, in cooking. So again, silang lahat 1 to 4 gases at room temperature and are used as heating fuels. Now, those alkanes with carbons 5 to 8 are liquid naman. They are liquid at the room temperature, but they are highly volatile. So they easily volatilized. And anong gamit ng mga alkanes natin with carbons 5 to 8? They are used to make gasoline. So mga pang-gasolina ito, pang-fuel natin, like for example sa car. At ano naman ito? Ito yung anong tawag dyan? Kung 5 pentane, 6 is hexane, 7 heptane, and lastly the 8th one, carbon number 8, or 8 carbons, we have the octane. So silang lahat liquid at room temperature and ginagamit as gasoline. Now, alkanes with 9 to 17 carbon atoms are still liquid at room temperature, but they do have high boiling points. And ito yung nakikita natin sa kerosene, sa diesel, and yung ginagamit as jet fuels para sa airplane na gasolina or airplane na fuel. Yan yung alkanes na 9 to 17 carbon atoms. So if you are going to differentiate, like yung sa gasolina natin sa car, yung gasoline talaga ha, regular one, and then the diesel one, mas mabilis talagang, mas mabilis yung car na gasolina yung fuel niya kasi highly volatile siya. Madali siyang sunugin para ang makina mag-function. Pero pag alkanes kasi na 9 to 17, they have high boiling point pa. Kaya nagpapainit muna ng makina, 'di ba, before ipapaandar yung sasakyan na gumagamit ng diesel. So yan yung kaibahan ng mga alkanes natin. Questions? So ang ibig sabihin yan, class, as the alkanes increase its number of carbon, nag-i-increase din ang kanyang boiling point. Okay? Now, how about those alkanes with 18 or more than that number of carbon? So since they are high, they have high molecular mass or high molar mass, they are actually solid at room temperature. Solid sila. Ito na yung solid natin na alkanes. And ginagamit, waxy sila na solid. So ginagamit sila as waxy coatings of our fruits and vegetables. Yan yung problem natin with our fruits and vegetables nowadays kasi nilalagyan nila ng wax para hindi agad malanta. So just like the apple, tingala kagwapo kayong apple, shiny kayo siya. So pwede na siya gibutangan og wax. And ang ginagamit na wax are those alkanes na merong 18 or more na carbon atoms. So yan yung mga gamit ng ating mga alkanes class. Any question or clarification about this? Wale? Sure na. So let's talk about the boiling points of alkanes. Actually, it is not necessary to memorize all the boiling points of alkanes as long as we know the pattern. Okay na yon kasi most of the time it's the pattern for the boiling points ang ina-ask. Edible ang wax? Yeah, edible ang wax. Our problem is medyo matagal din siya i-digest ng ating digestive tract, ng ating GIT. Actually, yung like sa mga noodles, mga kinakain natin na noodles, ilalagyan din nila ng wax. Yan. Kaya it is not advised to eat noodles na pirmi gani. Sa in a week kapila ka mukaon og noodles. Remember, meron yan silang waxy coating. And ayun, makain mo siya. And I think it takes at least 2 weeks for it to be removed by the body. So it's not good for you to eat a lot of noodles like in a week kapila or like adlo-adlo di ba siya kaunon. Mostly sa mga naga-board adlo-adlo kaon og noodles. So do not do that. Na? Aside sa aside sa salt and sa MSG, meron tayong siyang wax. Okay? Okay. Kasi pati candle wax. Candle wax, ginamutang sa fruits? No, we don't really do that. Pero actually, yung candle wax natin is still an alkane with daghan nga number of atoms. Dili edible ha, dili edible. Lain na po. Okay. Now, for the pattern sa boiling point natin, take note that alkanes have the lowest boiling point compared to all the other organic compounds or organic functional groups that we have. Now, the pattern, nag-i-increase yung boiling point as we increase the molecule. Okay? Meaning yan, kapag nagkakaroon ng more number of carbons, there will also be increase in the boiling point. So the reason is there is also an increase in the force involved. So remember, the bonding between these carbons involve energy or force. So as you have a larger molecule, it will mean na matagal mo din siyang i-boil. However, that is not true for the branched alkane. If it is a linear alkane, again, linear alkane lang siya, or aliphatic alkane lang, diretso-diretso na carbon-to-carbon bonding, nag-i-increase talaga ang boiling point as we increase the number of carbons. But for the branched alkanes, pag nag-branch na yan siya, nagde-decrease na ang kanyang boiling point. Okay? Again, nag-decrease na yung boiling point because the energy involved in the branching is most of the time weak and madali siyang i-destroy. So, madali ding mag-boil ang ating branched alkane. But the boiling point increases as there is a ring formation. So for cycloalkanes, there will be higher values for the boiling point. So please know this pattern. Again, no need to memorize the boiling points of the alkanes. Daghan kayo na sila mabuang ta. Basta kabalo lang mo sa pattern na to with our boiling points. Okay, now the hydrocarbon in our crude oil is being separated through the process of fractional distillation, and that actually involves the concept of the boiling point. So when you say crude oil, yung oil na kinukuha nila sa underground, 'di ba? Like in the Middle East, daghan kayo sila store sa baba ng lupa ng crude oil. But again, crude oil siya. Crude nga siya, nag-undergo lang siya ng collection. So kapag pre-process mo na siya, that's the time we get the different hydrocarbons or the different yung types of like gasolines that we have. Makukuha natin yan siya through fractional distillation. So if like we boil the crude oil, magbo-boil naman talaga siya during the process of distillation. So yung unang magbo-boil, syempre, yun din yung unang mag-e-evaporate and unang mako-condense, and therefore yun din ang mauunang makuha during the distillation. So remember, distillation is used to separate mixtures. And most likely, for example, the gasoline, since kung balikan natin, yung mga gasoline natin, they are alkanes with 5 to 8 atoms. Most likely, sila yung unang makukuha during the fractional distillation of our crude oil. And then, followed by other alkanes and including the diesel. Okay? So, maiiwan si diesel class kasi nga, since it has a lot of carbons, matagal siya mag-boil. But the residue for our crude oil is the so-called asphalt or the tar. So yan yung ginagamit talaga like pang-aspalto sa mga road. So that is the reason why the road will be slippery if it is it's made up of asphalt. Kasi galing din siya sa crude oil. So be careful when driving. Take note of this. We separate the components of our crude oil through fractional distillation, and that is dependent on the boiling point of the components. Okay, now reactions to consider for our alkanes. Number one reaction here is the combustion. Again, our alkanes undergo combustion. This involves actually oxidation, meaning the alkanes can react with oxygen. Oxidation yan siya, and the process is called combustion. And for complete combustion class, always ito na the products will be carbon dioxide and water plus the heat. So kaya when we use the butane, so example, itong alkane here na nakalagay is butane, and when it reacts with oxygen, you will get the carbon dioxide, the water, and you will get the heat. So kaya ginagamit natin siya for cooking. Okay, so parehas ng inyong ginahimo karon, di ba, nagaluto mo sa inyong panihapon karon, sana all ako dili makaluto. Kaya kung man naga-istorya, you are actually using alkanes their class na low molar mass kasi mababa yung number of carbons. Most likely butane, pwede din namang ethane or propane. Pwede din methane actually. So that is also the reason yung sa mga septic tank, 'di ba? Septic tank. Yung mga kasi natin, mga waste materials are being degraded into methane. Most of the time it is methane. So like if you are going to anong tawag dyan? Magsisindi ka ng lighter or yung posporo in a septic tank, talagang sasabog yan. As the process is combustion. So again, in the presence of oxygen, you will have the heat. However, there are alkanes, especially if kulang yung supply of oxygen, incomplete combustion lang ang mangyayari. Again, this happens when there is not enough source of oxygen. So just like in the Bunsen burner, diba, the Bunsen burner is being connected in the gas source, and if you are going to open the air hole, you will have enough oxygen and you will have the non-luminous flame or the blue flame. But if you're going to close or half close the air hole, then you will have the luminous flame or yung yellow flame na tinatawag, which is less hot compared to the non-luminous flame. So the reason for that is there is incomplete combustion. There is no enough oxygen na magre-react with your alkane. So what is the difference with the product? You can still get the carbon dioxide, the water, but you can still have the heat here, but there are extra products. So we have here the carbon monoxide and the carbon itself, the elemental carbon, which we call soot. Yan yung nag-iitim sa example kung sa laboratory, we are going to use the evaporating dish, 'di ba? Ang puwet ng evaporating dish magiging black. So, yun yung palatandaan, class, na incomplete combustion ang nangyayari. That is also true kay nagluto man mo din no. That is also true sa inyong mga kaldero. Pag umitim na yung puwet ng mga kaldero nyo dyan, meaning incomplete combustion ang nangyayari. So there is no enough oxygen that reacts with your source, your gas source there. Kaya nagkakaroon ng formation of soot. That's the carbon that will be deposited in your equipment. Okay? Question or questions, clarification? Wala. Kasi nabot man taan na, no? This one is really asked in the board exam. Products of combustion of alkane. Either complete or incomplete. And the most significant there is for incomplete combustion, there is always the formation of this one, the soot. Okay? And then for cycloalkanes, class, cycloalkanes are just alkane but they form rings. So single bond pa rin, pero again, they will form rings. So any shape, depending on the number of carbons. Like when you say cyclopropane, prop means 3 carbons. So we have here like a triangle. Ay, nasubra. Ulit. So we have here like a triangle. So tatlong carbons yan siya. For the cyclobutane, syempre butane is 4. So we have like this one. And the pentane is like 5. 5 carbons. So 1, 2, 3, 4, 5. So again, when you say cycloalkanes, they are still alkanes, so single carbon to carbon bonds pa rin, but they form rings. Okay, any question about our alkanes? Paki-review yung naming ha, and the way we make the different types of formula, molecular, empirical, condensed, or the structural formula. Wala? So let's move on. Taman lang ta, depende kung, actually ako ang i-include sa ako ang exam, taman alcohol. So I hope we can finish that. If ever I cannot finish the alcohol until 7:30 tonight, I'll be giving you a recorded discussion for the remaining topics since I have already submitted the exam and na-print na to siya. Okay, now we have the alkenes. So sa alkenes naman, this is still a simple hydrocarbon, but this involves double bond. Again, double bond between a carbon and another carbon. So si alkane, ang tawag ay paraffin. This time naman, alkenes are called olefins. And for the naming, for the nomenclature, they follow the rules sa naming ng alkanes. Meron lang tayong idagdag, just like the ending of the name will not be "-ane" anymore. Instead, it will be "-in". So later, we will have an example. Now, for the hybridization, meaning the merging of the orbitals of the electrons, alkenes class are sp2. They have sp2 hybridization. And because of that merging of the orbitals, their shape will also be different. This time it will be planar because the bonding's angle will be 120 degrees. So balikan natin yung table kanina. Susulat ko siya again. Group and then hybridization here. We have like 1, 2, 3, 4, and then S, SP, SP2, and SP3. So, paano siya naging SP2? Example, we have this alkene. Pag may double bond, SP2 talaga yan siya, class. Okay, so we are going to count. This one is an ethene, 2 carbon double bond. So, ethene ang tawag natin dyan. Now, how do we count the groups? The groups, class, are those na attached sa carbon. So, like, this is counted as 1, 2, and this one is counted as 1 only. This double bond here is counted as 1 group. So, all in all, this carbon has 3 groups bonded to it. So, kung tatlong grupo, ang kanyang hybridization is sp2. This is also true for this carbon. So, do not forget the presence of the double bond will give us an sp2 hybridization. So, please copy this table here for you to be guided with the hybridization of the orbitals for organic chemistry. Now, for the general formula, di ba, remember alkanes class C is CnH2n plus 2. This time for alkenes, we follow this general formula, CnH2n. Therefore, if you have a 2-carbon alkene, this will be C2H2 times 2, kasi N is the number of carbon. So, the correct chemical formula for a 2-carbon alkene is C2H2. Okay, so please again follow this general formula for our alkenes. Okay, so this is what you call the planar class, planar shape. This is true for our alkenes. The bonding or the angle between one group to another group will be 120 degrees. Again, sp2, this is due to the sp2 hybridization. When you say sp2 hybridization, one s orbital will merge or will be hybridized with the 2 p orbitals. So supposedly, di ba, we have 3 p orbitals, but in this case, only 2 p orbitals will be hybridized with the s orbital. Okay, that is how we distribute the electrons for our organic substances. It's a bit complicated compared to the inorganic chemistry. Now, for the naming of our alkenes, how do we name our alkene class? That's the same thing with the alkanes. We have to look first for the parent chain. And remember, the parent chain is the longest chain, but you have to make sure that in counting the longest chain, the double bond should be included. Okay, basig nag-count mo og parent chain or longest chain, and then you did not include the double bond. Kaya himuon ninyo siya og branch. So it's a no-no. You have to include the double bond in the counting of in the identification of the longest chain. Now, another thing that you have to take note in the naming of the alkenes is the numbering. Diba mag-a-assign tayo ng number sa parent chain. Now, you will start in the end that gives us the lowest number of the position of the double bond. Remember, sa alkane, magsa-start tayo doon sa side wherein you will have the lowest number for the branching. This time, we have to consider first the double bond. Kailangan magsa-start ka sa side na magkakaroon ka ng lowest number for your double bond and not for the branching anymore. Double bond na tayo. yung ating reference in assigning the numbers for the parent chain. But yung numbers na pag-assign, gagamitin pa rin natin in the naming of our substituents or our branching. Okay? And we also have to indicate the number of the double band. So in naming, we have here examples. So we will still be using the root words or yung prefixes natin depending on the number of carbons. And this time, this will end with in. So we have carbon, example, we have here 2 carbons banded together using a double band. So this will be eth, but this time mag-i-end siya sa in. So we call this one, sa IUPAC naming, we call this ethene. The ethylene is, class? A common name. The IUPAC name is the ethene. And then we have here another one, 1, 2, 3. So we have 3 carbons. For 3 carbons, our prefix is prop. But since you have the presence of the double band, you will have the ending in. Okay, so we call this propene. Now, this is true for alkenes with 2 to 3 carbons only. If it is already 4 or more na carbon, that's the time we are going to locate the position of the double band. And again, pag 4 na siya or more ng carbons, kailangan na tayo mag-locate ng position of the double bonds. Like this one, these are just 4 carbons, 4 carbon alkenes. Like we have 1, 2, 3, 4. So this is but plus the in. So we call that butene. But since 4 carbons siya, kailangan na natin i-indicate. Now remember, we are assigning number doon sa side na meron kang lowest number of the double band. So hindi ka pwede, class, mag-start ng numbering here. Hindi ka pwede mag-carbon number 1 there kasi masyado nang malayo si double band. So you will really, excuse me, start here. This will be carbon number 1, 2, 3, and 4. Okay, 1, 2, 3, and 4. Therefore, the double band class occurs at carbon number 1. That is why we name this as 1-butene. Okay, you have the option to whether use this format, 1-butene, or you can use this format, but for the 4 carbons, 1 for the position of the double band, and syempre since double band, mag-i-end siya sa in. So either of the two is accepted for the IUPAC naming. 1-butene or but-1-in. Now, anong kaibahan nila? Take note of this. We still have 4 carbons here, but this time the double band is in carbon number 2. So you can number anywhere, 1, 2, 3, or 4. Pwede ka ding 1, 2, 3, or 4. Parehas lang naman that the double band is found at carbon number 2. So this is called 2-butene or but-2-in. Okay? This is how we name, class. Now, pag may branching, syempre, isusulat nyo pa rin yung branching here, and that will also follow the rules ni alkane. So, gagamitin pa rin natin yung number kung saan nakaposisyon si branching, and at the same time, we will still arrange them alphabetically. Okay? Alphabetical pa rin yung pagkakasunod-sunod niya. Now, sa alkene again, our reference will be always the double band. Doon tayo magsa-start sa end kung saan mas malapit yung or mas mababa yung number ni double band. Pero kung for example like this one, na pantay lang naman whether you start here or you start here, nasa carbon number 2 pa rin yung double band, okay lang. Pero kung meron siyang branching, class, like example, merong branching, kung example, mahaba ito ha, tapos whether you start on the left or the right, parehas pa rin yung location ng double band, dun mo isasali sa pag-consider yung branching. So kung saan na side ang magkakaroon ng lowest number of the branch, doon ka mag-start. Okay? Applicable lang yun siya kung yung position ng double band is the same either of the 2 sides. Okay? questions or clarification? Let's move on. So we have here the Alkadians. We call this Alkadians because of the presence of two carbon-to-carbon double bonds. So dalawang double bonds yung nasa structure. Again, we call that Alkadians. Now, how do we name this? Indicate the position of the double bond plus the prefix, and ang ending niya ay magiging diene. So just like this one, we have 4 carbons here and then we have 2 double bonds. Now you just have to indicate the position of the double bond. So if we are going to assign numbers here, the double bond happens or occurs at carbon number 1 and carbon number 3. And then the prefix, that prefix is for the number of carbons. So you have but or buta, and then the word, the ending diene. So this is the name of the example. 1,3-butadiene. So di means you have 2 double bonds. So again, we call this one as Alkadiene. Okay? Next, forces involved both sa Alkadienes and sa Alkenes, pareha sila ng alkanes. They are also involved, or they also involve van der Waals forces or van der Waals interaction, and that is the reason why they have low boiling point and low melting point also, because the interaction or the force is weak. And they can also do hydrophobic bonding. So that is the reason why you cannot mix these organic substances, alkanes and alkenes, sa water kasi they are hydrophobic. Okay, now let's move on to the reaction of our alkenes. Please listen, I included this sa exam. So sa exam, you have to predict the products of the products of the reaction. So number one reaction, yung sa alkanes kasi combustion lang. This time medyo marami sila. Number 1 is electrophilic addition. Okay, electrophilic addition, meaning we will add an electrophile or an electrophilic group doon sa ating alkenes. So pag sinabing electrophile class, that is electron loving, yung charge niya ay positive. So electron poor siya kasi nga electron loving. Kulang siya ng electron kaya gusto niya ng electron. So kaya electron loving siya. Na pag sinabing nucleophile, ito yung nucleus loving, negative ang kanyang charge, and electron-rich siya. So baliktad sila ni electrophile. Electron-rich siya, marami na siyang electron. So gusto niya ng nucleus. Remember what is in the nucleus? We have the protons. And protons are positively charged. Now take note, class, that our alkenes are electron-rich. Okay? Again, our alkenes are electron-rich. That is the reason why kailangan nila, maa-attract sila. And remember sa chemistry, opposite attracts. Maa-attract sila sa electrophile. So in the presence of an electrophilic reagent, there will be the so-called electrophilic addition. So ito yung examples of the or types of electrophilic addition. So number 1, we have here the hydrogenation reaction. Wait lang, low bat. Again, we have here the hydrogenation reaction. From the name itself, we have here hydrogenation. Hydrogen class is an electrophile. This is electron poor. So this will be attracted to the electron-rich alkene. So for example, we have here an ethene. And then you have here the presence of this hydrogen. Now, this will only happen in the presence of a catalyst. Remember, catalyst class, anong ibig sabihin ng catalyst? They speed up the chemical reaction. Okay, again, they speed up the chemical reaction. Now, what will happen? What will happen to this reaction? This hydrogen will be distributed to each carbon. And mawawala yung double bond. Kaya yung product class will be an alkane. So you will have here C and then C. Remember, meron siyang dalawang hydrogen originally. And since nag-add tayo ng hydrogen sa bawat carbon, then this will be now the product. Okay, so from ethene, remember we call this an ethene, plus yung hydrogen, magkakaroon ka ng ethane. Okay, so this will be the product. That is true for the hydrogenation. Electrophilic addition ito because this one is considered an electrophile. So the possible catalysts that we can use in the hydrogenation reactions are the following: platinum, nickel, and palladium. Okay? Platinum, nickel, and palladium. Questions about this one? If I'm going to give you sa exam an example of this, you just have to make sure that the hydrogen will be distributed on the carbons involved in the double bond. The rest of the carbons that are not involved in the double bond will remain the same. And always remember the product will be an alkane. Mawawala si double bond. Okay? Now, another example here is the halogenation. Halogens. The halogens are also considered as electrophile, and we need the same catalyst here as the hydrogenation. So alkene pa rin, example ethene. We have ethene pa rin here, class. And then in the presence of a halogen, remember halogens are included in our diatomic molecules. Yung diatomic molecules natin, di ba? The bridge. No, they don't exist as single atom in nature. Always sila diatomic. So, nandito rin si hydrogen, kaya meron tayong H2 kanina. Now, for our halogens, it can be a bromine, chlorine, iodine. Okay, this is for chlorine. And fluorine also. So in this case, unahin natin si chlorine ha, but it can be bromine, it can even be iodine or fluorine. So for chlorine class, example, you have Cl2. Kagaya lang sa hydrogenation ang ating reaction. This will still be distributed to each carbon. So in the end, you will have a haloalkane. Mawawala yung double bond, so alkane siya, pero haloalkane na siya kasi meron ng halogen. So ito na yung magiging product niya. You have originally 2 hydrogens here, and then again, you will have the 2 chlorines being distributed sa bawat carbon. Okay? So this will now be called dichloroethane. Okay? So again, this will now be called dichloroethane since we have 2 carbons. Ay, 2 chloro di ay, and then 2 carbons. Okay, pwede to be specific, that's 1, 2 dichloroethane para specific talaga na both on the 2 carbons. Okay, that is for halogenation. Now, number 3 for our types of electrophilic addition is the hydrohalogenation. So, ano naman ito? Hydrohalogenation, that's hydrohalogen or yung mga acids natin. They are also considered electrophiles. So the same, we have here an alkene, and then in the presence of a hydrohalogen, example hydrochloric acid, magkakaroon ng electrophilic addition. So ang mangyayari, one carbon will receive the hydrogen and the another carbon involved in the double bond will receive the chlorine. Okay, so we have here example this one. you have here CH, chlorine pala yung nilagay ko dyan. And then magiging single bond na lang siya. And then you have here another carbon that will receive the hydrogen. So we still call this haloalkane or alkyl halide. Okay, ito naman ang tawag naman natin dito is chloroethane. So isa na lang ha, isang chlorine lang siya. Now this type, itong actually dalawang ito will follow the Markovnikov's rule. Markovnikov's rule. So that is pronounced as F ha, ang V sa kanila, Markovnikov's rule. Anong sinasabi or anong rule na ito? In hydrohalogenation or hydration, the hydrogen will be given to the carbon with greater number of hydrogen. Okay? Again, according to Markovnikov's rule, the hydrogen for both hydrohalogenation and hydration will be given to the carbon involved in the double bond with the greater number of hydrogen. And the chlorine or yung halogen natin or yung OH natin for the hydration will be given to the carbon with lesser number of hydrogen. So okay lang itong ethene class. Okay lang ang ethene kasi dalawang carbon lang talaga ang involved and they have the same number of hydrogen. Pero in the case class na hindi na magpapantay yung number of hydrogen nila, you follow the Markovnikov's rule. So, an example of that, meron tayong propene. Merong double bond here. And then you have hydrogen, another hydrogen. And this time, 1, 2, kulang siya ng hydrogen. So example, ito yung propene natin. And there is a reaction with hydrobromic acid. So ito na yung papasok si Markovnikov's rule class. Kasi hindi napantay yung hydrogen of the carbons involved in the double bond. So ano yung rule ni Markovnikov's? The hydrogen daw will be given to the carbon with greater number of hydrogen. So in this case, ito lang naman yung carbons involved in the double bond. So in this case, class, the hydrogen will be given here in this carbon kasi it has more number of hydrogen. And then the bromine will be given here, the carbon at the center, since isa lang ang kanyang hydrogen. So ang kanyang magiging product, haloalkane pa rin, pero the position will be like this. Itong carbon na ito, the same pa rin, pero the carbon at the center will have an H and the bromine. So nasa kanya si bromine, and then yung carbon sa last one will have 3 hydrogens na. Okay, that's how you decide if, for example, sa hydrohalogenation and sa hydration, paano mo i-distribute yung bawat component of the electrophile. Okay, questions? Questions about this? That is also true for hydration ha. So like in the case of the same parent propene, you have CH3, CH double bond CH2. I-abbreviate ko lang ha, condensed formula ito nitong nasa taas. Pero this time it's the water. And para mas madali siya yung water, gagawin nating HOH. Ayan. So, sa hydration process, this again will still follow the Markovnikov's rule. Hydrogen will still be given on the carbon with lesser hydrogen, but the OH will be given on the one, ay baliktad. Baliktad akong arrow. Ulit. Baliktad akong arrow. Okay, the hydrogen will still be given here on the carbon with greater number of hydrogen, and then the OH will be given here at the center since it has lesser hydrogen. So this will now be the product. You will still have the CH, but you will have the carbon there will have the OH. Mawawala yung double bond ha, and then this will become CH3. So nadagdagan siya ng isang hydrogen. Okay, that's the 4 types of electrophilic addition na pwedeng mangyari with the alkenes. Again, alkenes are nucleophiles. So they are attracted to electrophiles. Questions, class, or clarification? Meron bang part dyan na hindi naintindihan? Or naintindihan naman? I hope naintindihan siya. Already 7:10. Still have 20 minutes. Now take note of this. Adding hydrogen to the double bonds in our vegetable oil will produce a compound with high melting point. And that compound will be solid at room temperature. So one example of that is the margarine. The margarine is actually derived from a vegetable oil that is being added with this hydrogen. So the process is hydrogenation. Yung alkane dito is a vegetable oil plus the H2, the product will be the margarine. So that's how we solidify our vegetable oil class. Dagdagan natin siya ng hydrogen, magiging solid na siya. So this is also asked sa board exam natin. The process of producing margarine is called hydrogenation. Okay, now testing for unsaturation. Remember, our alkanes are called saturated hydrocarbons. They are saturated with a lot of hydrogen because they only involve single carbon-to-carbon bonding. Now this time, both our alkenes and alkynes are called unsaturated hydrocarbons. So due to the presence of the double or the triple bonds, there will be less hydrogen atoms involved in the formula. Now, for us to know whether a sample is saturated or unsaturated, we do this test. So, number 1, we may do the bromine test. So, if bromine class is added to an alkane, there will be a red color na solution, and that is due to the bromine ha. So, the red color of the bromine will persist. Hindi siya mawawala. But if the sample involves either a double bond or a triple bond, so it's an alkene or an alkyne, the red color of the bromine will disappear immediately. So that's how we differentiate alkanes from the two, alkene and alkyne. And then another test, aside from the bromine test, we also have the Bayer's test. This Bayer's test naman uses potassium permanganate, or remember the common name for our potassium permanganate is mineral chameleon. Now, in the presence of a double bond or a triple bond, remember potassium permanganate is color violet. Pag meron kang presence of unsaturated organic hydrocarbons, or alkenes or alkynes, the violet colored solution will turn into brown. Okay? Because potassium permanganate or the permanganate ion there will be reduced into manganese dioxide, which is color brown. So these are the two tests to differentiate saturated and unsaturated hydrocarbons. Questions or clarifications before we'll move on? Wala? Sure na? Sure na gyud? Wala questions or clarifications? Kasi we will be moving on into our alkynes. So si alkynes naman, syempre, merong triple bonds. Okay, this is triple carbon to carbon bond. And this time, the general formula will be CnH2n minus 2. So this will contain lesser hydrogen compared to both alkanes and alkenes. CnH2n minus 2. So just like when you have a 2-carbon alkyne, so you will have C2H2 times 2 minus 2. N will still be the number of carbon. So you have C2H4 minus 2. The correct chemical formula is C2H2. That is how we use the general formula for our alkynes. Now for the hybridization of the orbitals. For alkynes class, we have the sp hybridization. So let me write again our table for this. Groups here, hybridization 1, 2, 3, 4. You will have S, sp, sp2, and sp3. Now, in the case of alkyne, na-erase na una ako. Ulitin ko siya sulat. Okay, for the case of alkyne, example, we have here an ethine. So, dalawang carbons, merong triple bond. And then you have a hydrogen. Remember, ang carbon dapat apat lahat yung kanyang bonds. Now, how do we count the groups? We have here 1. This is counted as 1. And this triple bond here is counted as 1 also. So, for our ethine, you have 2 groups. So, dito siya. So, pag 2 groups, the hybridization is sp. Meaning, 1 s orbital will be hybridized and be merged with 1 p orbital. So that is for the alkynes. This is true for the triple bonding. Pag may triple bonding, the hybridization will always be sp hybridization. Okay, and this time, the shape of the molecule will be linear, and the angle between one group to another will be 180 degrees. So this is sorry, I don't have an example pala of the alkyne, but ganito yung magiging mukha niya, class. If you have a carbon there and then triple bonded with another carbon, yung hydrogen dito talaga siya. So hindi siya liliko. This is 180 degrees. Linear yung ating alkynes. And then that is again due to the sp hybridization. Now, ano naman yung mga reactions involved sa ating alkyne? So, dito, we have the so-called catalytic hydrogenation and hydration. So, number 1, let's start with the catalytic hydrogenation plus. Example, you have a carbon to carbon triple bond, and then you have the hydrogen. Ayan. And this will be reacted. Hydrogenation, meaning hydrogen. You have the H2. So, ganun pa rin. I-distribute mo pa rin itong dalawang hydrogen involved doon sa carbon involved in the triple bonding. And this will result to an alkene. Again, this will result into an alkene. So, since na-distribute siya, double bond na lang ito, and magkakaroon ka ng dalawang hydrogen for each carbon. So, again, the process, the product of catalytic hydrogenation of our alkyne is an alkene. So, this also involves catalyst. It can be a platinum, pwede din siyang palladium or nickel. If you have more catalyst and more hydrogen, actually pwedeng mag-proceed ito sa alkene hydrogenation. So ang ending pa rin, pag meron ka pang more hydrogen and meron ka pang catalyst plus, ang ending nito will still be an alkane. Okay? Pero kung kulang, hanggang dyan ka lang. Sige, that is again called catalytic hydrogenation. So, ang number 2, we have the hydration. Different si hydrogenation sa hydration. Na hydrogenation, hydrogen lang talaga ang i-add. Pero pag sinabing hydration, we are adding water. Okay, so like we have this one. We will add water plus. So ganun pa rin yung reaction natin. I-HOH ko lang siya ha, para mas makita yung distribution. So ito will be distributed to the carbons involved in the triple bond. And you will have double bond here, pero this time, the one will bear hydrogen, 2 hydrogens na siya, and then this one will have the hydrogen and the OH. Okay? So ito yung magiging product niya. So this one will be called an enol. Bakit enol? Kasi double bond na may alcohol. Ang tawag natin dyan enol. But actually, itong hydration of the alkene can also proceed. Pwede din siya mag-proceed sa reaction. The reaction will be called tautomerism. Ito yung tinatawag natin na tautomerism. Ang ibig sabihin yan, there will be a rearrangement. Rearrangement. Okay, pwedeng mag-proceed yung reaction natin. After the enol, pwede siyang maging ketone. So mawawala yung double bond. Magre-rearrange tayo. You will have the hydrogen, and then another hydrogen will be rearranged here. And then this time, itong carbon na ito, siya na lang yung magbe-bear ng oxygen, and then you will have here another bonding. So, kung hydrogen pa rin ito class, this will only be an aldehyde. Pero kung meron pang isang functional group dyan, kung example 3 carbons tayo dito, magiging ketone ito siya. Okay, so yan yung magiging reaction of the hydration of the alkynes. Kung hydration lang talaga, hanggang dito lang siya. Pero again, there will be the tendency for the reaction to proceed sa rearrangement. And if you have more than 2 carbons, yung kanyang product will be a ketone. So yan yung mga reactions of our alkynes. Any question, class? Any question or clarification? Or nanihapon na mo din ha, sana all? Wala. So we have other functional groups. We have the halides. The process will still be called halogenation, wherein you will also distribute the halogens to the carbon involved in the triple bond. Okay? So pwedeng fluorine, chlorine, bromine, and iodine yan siya. Siguro dyan lang ako mag-stop since it's 7:23. I will make a video na lang of the aromatic compounds hanggang this one, alcohol. Hanggang dito ako sa alcohol for my coverage for the prelim exam. And then from phenols hanggang sa end, that will be included sa midterms. Okay, questions sa mga na-discuss natin this evening. Alkanes, alkenes, and alkynes. Meron ba kayong gustong i-clarify? Again, phenols pababa ha, hanggang end will be included sa midterm na. Now sa prelim, hati yun siya. Meron akong kinuha na questions doon sa inorganic or sa Gen Chem. Yung sa video ni Sir Franz na binigay ko sa inyo. And then mga 40% of the exam will be the Gen Chem, and then 60% sa exam natin will be organic chemistry. I hope clear yun siya. Any clarification about the exam?